AI incidents are more than technical failures. They are governance events. In this section, we'll connect detection, triage, containment, evidence, and remediation into a certification-ready response model that architects can design into AI systems from day one. We have already built the foundations: ISO 42001, governance, architecture, MLOps, and LLMOps, monitoring, and security. Now we bring those capabilities together for operational response. The focus is what happens when AI fails, drifts, is misused, or causes harm, and how the organization responds, learns, and improves. An AI incident is about impact. The system creates harm, exposes unacceptable risk, fails operationally, or triggers legal or ethical concern. A nonconformity is about governance. A required AIMS process, control, approval, assessment, or monitoring activity was not followed. The two often overlap. A biased model output may be the incident, while the missing bias review is the nonconformity that allowed it. ISO 42001 expects both responses. Fix the technical problem, then correct the management system so the same failure is detectable, traceable, and less likely to recur. AI incidents become manageable when teams classify them consistently. Start by identifying what went wrong. Did the system create harmful or biased output, expose data, fail operationally, or get misused outside approved governance? That category points to the likely owner and the first containment move. A privacy failure may require access shutdown and notification. Model drift may require rollback and closer monitoring. A harmful decision may require human review and customer remediation. Consistent categories also make evidence repeatable, so teams can compare incidents, spot patterns, and improve controls instead of treating every event as unique. Severity classification keeps organizations from treating every AI incident like a crisis, or treating a crisis like a minor defect. The rating should reflect actual and potential impact: harm to people, users affected, regulatory exposure, security risk, business disruption, and reputational damage. AI's factors such as vulnerable populations, irreversible decisions, autonomy, human override, and how quickly model behavior can spread. Use clear levels from low to critical with defined escalation and notification rules, and keep reassessing. Early facts are often incomplete, and severity can change quickly. Good incident management starts before anyone declares an incident. Signals need to come from many channels because AI failures appear in different ways. Monitoring may catch drift, toxicity, bias, hallucinations, abuse, or anomalies. People may report confusing outputs, harmful behavior, support issues, or reviewer escalations. Security and compliance tools add alerts from SIEM, DLP, access violations, audits, privacy complaints, and regulators. The key is disciplined intake. Every signal becomes one standard incident record with time, system, severity, owner, evidence, and initial classification, so the right response team can act quickly. Triage turns a reported event into a controlled response. First, validate what happened and confirm the scope: the AI system, model version, data source, users, process, geography, and regulatory context involved. Then classify the event correctly, because an AI incident, nonconformity, security event, privacy event, or operational issue may require different authorities. Priority comes from severity, urgency, spread potential, reversibility, and stakeholder impact. Once priority is clear, assign an owner and escalate to the right leads. Finally, record the rationale for every classification, escalation, downgrade, closure, and immediate action. Containment is the stop the bleeding phase. At this point, you are not proving root cause. You are limiting blast radius. In AI systems, containment can happen at several layers. You might disable an endpoint, throttle traffic, revoke keys, or block high-risk prompts. You might roll back a model, freeze retraining, quarantine corrupted data, or suspend retrieval from an affected knowledge base. When automation is the risk, root decisions to humans require dual approval or raise thresholds. Strong containment balances four things: reducing harm, keeping critical services running, preserving evidence, and meeting regulatory duties. Root cause analysis should not stop at the visible failure. A bad output may trace back to a model defect, data drift, prompt injection, retrieval error, configuration change, or security compromise. It may also reveal a process weakness such as weak approvals, unclear ownership, poor testing, or missing human review. The goal is to connect evidence to causes: logs, prompt traces, data lineage, evaluation results, access records, and deployment history. Separate the proximate cause from the deeper system weakness. Then fix both, so the same class of incident is less likely to recur. Communication during an AI incident is not just a courtesy, it is part of control. The right people need the right facts at the right time. Internally, governance, legal, privacy, security, risk, system owners, support, and executives need enough information to coordinate decisions. Externally, customers, affected users, regulators, partners, auditors, and vendors may need notice based on severity, jurisdiction, and contracts. The message should state what is known, likely impact, interim mitigations, next steps, and support options, while avoiding speculation or false certainty. Remediation should match the failure mode. If a release introduced harm, rollback is often fastest. Return to a known good model, configuration, or feature state while change control catches up. If the model learned the wrong patterns, retraining or recalibration addresses the root cause in data, thresholds, or fine-tuning. If the behavior is generally acceptable but unsafe in certain contexts, adjust guardrails, filters, permissions, retrieval limits, validation, or human review. When the gap is organizational, update policy, approval gates, procedures, monitoring thresholds, and escalation rules. Good remediation is evidence-based, not cosmetic. Corrective action is where an incident becomes organizational learning. Start by defining the issue clearly, then identify the true root cause, not just the visible symptom. From there, choose an action that changes the control environment. Assign an owner, set a due date, and define what successful completion looks like. Updates might include stronger monitoring, revised risk assessment, tighter access control, new model tests, or added human oversight. Finally, verify effectiveness before closure. If the action is recorded but recurrence risk is unchanged, the management system has not improved. Recovery is not just turning the system back on. Treat it as a return to service gate. First, prove the technical fix holds with regression tests, safety checks, bias reviews, red team scenarios, performance benchmarks, and security verification. Then confirm governance readiness, updated risk assessment, approvals, stakeholder sign-off, and explicit acceptance of any residual risk. If confidence is not complete, restore in phases: sandbox, limited release, canary deployment, then production. Even after return, keep monitoring elevated because recurrence and secondary effects often appear only under real operating conditions. An incident is not finished when the service is restored. For ISO IEC 42001, it must leave a traceable record: what was detected, when it happened, who decided what, which model version was involved, what notifications were sent, and which corrective actions followed. Those records become metrics, such as time to detect, contain, and remediate, recurrence rate, severity trends, and closure rates. Management uses these patterns to reassess risk, plan audits, allocate resources, and improve the aims. Good evidence proves controls are not just documented, they are working in practice. Incident management is where governance becomes operational. Incidents can involve technology, ethics, privacy, compliance, security, operations, or human oversight. A mature workflow detects, triages, contains, analyzes, notifies, remediates, validates, documents, and escalates. Most importantly, lessons learned must improve controls, models, policies, training, monitoring, and architecture. Next, we move into implementation methodology and certification readiness.